Fourth sem, the topic we will discuss today is endospore formation in bacteria. Now, endospore are intracellular spore. What does an intracellular spore? Intracellular spore means if this is a cell, they are formed inside. They are formed inside the cell. That's why they are known as endospore. Now this endospore is also known as exosporangium. Okay, they are known as exosporangium. Now endospore are mostly formed in gram-negative bacillus. So these, gram-positive bacillus. Now most of the endospore are formed by this bacteria, the gram-positive bacillus, and these spores are formed during starvation. What do you mean by starvation? When there is deficit of food, for example, proteins. Okay, when there is a deficiency of food, that is, the cell is starving, then how will this bacteria survive? It will survive by forming an endospore inside the cell. And instead of living in this huge room, that is the cell, the bacteria will confine its life to this single small room inside, and that is known as the endospore or the exosporangium. So it will leave this luxury behind. It will live inside a small cell, inside a small room. Okay, it will not live inside a big room because too much of expenditure, and it is starving. Okay, that's why it will confine its life to a singular cell, and that cell is known as an exosporangium or an endospore. Then one more thing, one bacteria, alright, it will give rise to only one endospore, which means one bacteria, one endospore. It cannot be from one bacteria you will get two endospore. That is not the case. One bacteria will give rise to one endospore. Alright, let us look at the position of endospore. Position or their location. Now based on their position, for example, if this is a bacteria, okay, this is a bacteria, and the endospore, it is formed here at the tip, okay, then this endospore is called terminal. Okay, it is called terminal because why? It is formed at the tip of the bacterial cell. Then, if this is a bacteria and an endospore is formed here, okay, this is called subterminal endospore. It is not formed at the tip, it is formed just a few millimeters below the tip, that is at the subterminal position. Then there are some bacteria, for example, if this is the bacteria, endospore is formed here in the middle. Okay, so this is called central or oval endospore. Mean the endospore, it is formed at the center. Alright, so based on the position of endospore, if it is formed at the tip of the cell, you call it terminal. If it is formed a few millimeters below the cell, you call it subterminal. Now subterminal can also be from this side like this. Okay, it is not that, it will be always be from this side. Alright, and if it is formed at the center of the cell, then that is known as a central endospore. Okay. Well, let us look at the steps involved in endospore formation. What are the steps involved in the formation of endospore? The first step is this. This is a bacterial cell. Alright. What do you call this bacterial cell? You call it as a vegetative cell. Now this bacterial cell, it has nuclear material. Now this nuclear material, you don't call it nucleus, but you call it as a nucleoid. Okay, it has nuclear material, and this nuclear material, it is called a nucleoid. Okay, in the first step, what will happen to this nucleoid, this nuclear material which is present inside the cell? These two nucleoid, or whatever nuclear material that is present inside the cell, for example, they will join together. Okay, this nuclear membrane, it will arrange itself and then it will form a linear axial filament. It is this in the form of fragments, nucleoid, DNA in the form of fragments. What happened to these two fragments? They will unite together to form a linear, a straight line, a linear axial filament. Okay, in the next step, see, this is a bacterial cell. You call this as cell wall. Now this bacterial cell, it has a cell membrane. Okay, it has a cell membrane, and this is the axial filament that was formed. Okay, what will happen in the third step? In the third step, this cell membrane, it will slowly invaginate like this. Okay, it will invaginate inside the cytoplasm. So cell membrane, or we call it as septa formation, because these are nothing but septa. Okay, so this is the third step. In the fourth step, okay, so this septa formation is more or less complete. Alright, it will give rise to a big cell and a small cell. Remember, that is the axial filament. Okay, septa formation is complete, giving rise to a big cell and a small cell. Alright, so in this step, what happened? The big cell will not take part in the formation of endospore. It is the small cell that will take part in the formation of endospore. So what will happen? This is cell wall. Okay, this is the big cell. Okay, it will not take part in septa formation. What happened to the small cell? It is like this. Yes. What happened to this? It slowly become more or less circular. When it becomes circular, it take in the nucleoid. Remember, look here. This is the nucleoid. This nucleoid is also inside the small cell. So this nucleoid inside the small cell, it will become fragment again, it will become particles again, it will become pieces again, it will be equally distributed inside the small cell. And this small cell, it is destined to form the endospore. So what do you call the small cell? The small cell is known as this pre-sporangium. It is known as the pre-exosporangium because why? It will give rise to the endospore or the exosporangium, this small cell. Okay, now in the sixth step, this is bacteria. Remember, this is the big cell, small cell. Now this is becoming a pre-exosporangium. This one, it will slowly forms an envelope around the small cell. Okay, it will slowly form an envelope around the small cell. This is the sixth step. Now in the seventh step, this is the big cell. Okay, it is slowly forming an envelope around the small cell, which is your endospore. Okay, it was like this. Now slowly this will disintegrate. Okay, and these two, they will meet. Okay, that is completion of septation. Then, sorry, this will not disintegrate, this will remain, and these two septa will make together. So what do you get? You will get just a small cell with an extra wall. So this is your endospore, and this is your big cell. It has become a coat. It has become a coat around the endospore. Okay. Now whatever is needed by this bacteria, it is contained in the small cell. It is contained inside the endospore. So the bacteria does not need this large room. Okay, because it is starving, it needs food. So if it uses all this area, it will need more food, and there is scarcity of food. And whatever is needed by the bacteria, it is inside the endospore. So what will happen? In the next step, the endospore will come out. This is your exosporangium or your matured endospore. This cell, the parent, it will lysis, it will break, it will burst. This is called autolysis because by itself it does the breaking. By itself it bursts to release what? To release the endospore. Okay, now this bacteria, big bacteria, now its life is confined to a small cell, and this cell will remain like this until there is sufficient food, until there is sufficient oxygen, okay, until the temperature is suitable for its germination. When these conditions are suitable, what will happen to this endospore? It will germinate and give rise to the same bacteria, this one that we started. Okay, from here it will give rise to the same bacterium that we once started. That's why one endospore will give rise to one bacterial cell. Now these endospore, they are highly resistant. They cannot be killed by heat. They are resistant to ultraviolet radiations. They are resistant to high temperature. They are even resistant to some pathogens. So they are highly hard structure. Okay, and a bacteria can live its life in this spore, and it will continue to do so as long as these conditions are not met: food, oxygen, and suitable temperature. If these conditions are not met, the bacteria will continue to live in the form of an endospore. Once the conditions are optimal, it will germinate and give rise to the original bacterial cell. That's why, okay, that's why if you take this endospore and see under the electron microscope, it is composed of a core. That is a core. What is inside the core? DNA. What else? tRNA. Again, what is needed? Enzymes. Okay. And the peptidoglycan. Alright. Surrounding this core, there is a wall. That is called the wall membrane. It protects the core. Then next to the core membrane, okay, is the core membrane. Alright, then it has additional coats. This is called the inner coat. Okay, then it has another coat. Alright, this is called the outer coat. What is there in the outer coat? In the outer coat there is protein, there is lipids, and there is carbohydrate. Alright, now this area, okay, it is also known as the cortex. So this is your endospore. Endospore is like this. You see under the microscope, this is the amplified diagram of endospore. A core where DNA, enzyme, peptidoglycan is there. A wall membrane that protects the core, a core membrane that protects the wall, an outer and inner coat, okay, which is also called the cortex, and the outer coat which is composed of protein, lipids and carbohydrates.